Hello friends, I am Sunil Sihemar and today I am going to discuss about the merchant circle diagram. This is very important topic for manufacturing or mechanical engineers and generally questions asked in the competitive exam and it is very important topic from the interview point of view. I will also discuss some of the questions that is generally asked in the interviews. So first of all I will discuss about the assumptions, generally which assumptions were this diagram. This concept of the diagram was given by the scientist Merchant. He developed this diagram to analyze the various forces which develops during the cutting action, cutting of a workpiece. So first I will draw a diagram just to conceptualize the various forces which takes place during the cutting. Suppose this is a workpiece, this is a job, and this is a cutting tool, and this is chip which is flowing in this direction with velocity vf. This is tool, this is workpiece. This chip is flowing with velocity vf and this is the cutting velocity vc, and this is the shear plane. This is the shear plane and the velocity of the shear plane is vs. Vs is the shear plane velocity. So first of all we will consider some of the assumptions that considered during to draw the merchant circle diagram. First is the cutting considered for the this machining operation was orthogonal cutting. Orthogonal cutting, I will discuss later about the orthogonal cutting, what is orthogonal cutting and what are the examples of the orthogonal cutting. But this is the one of the assumptions that the cutting was orthogonal and the tool used was the single point cutting tool. Cutting is orthogonal cutting, and tool used was single point cutting tool. So next assumptions is the chip behaves as a rigid body and it is flowing with uniform velocity vf. Chip behave as a rigid body and flowing with velocity vf. Okay, next, the edge of this tool is perfectly sharp and straight. Edge of tool sharp and straight. Next, suppose this is the width of this workpiece and similarly this will be the width of this chip also, width b. The width of the chip will before and after cutting will remain constant. Chip width constant. One of assumption was also that this is the flank surface of the tool. This is the rake surface. So flank surface will not touch this machined region, machined surface, and this shear plane, the stress at the shear plane, this is the shear plane. The stress at the shear plane will be the maximum stress and it will be constant, remains constant. So the shear plane stress maximum. One of the assumption was like the volume before cutting and volume after cutting will remain constant. Volume will be constant. So these are the main assumptions, and next I will discuss about the use. What are the use of the merchant circle diagram? So this diagram is particularly used for the to determine the various cutting forces which involved in the cutting operation. Why we are determining these forces? What is the use of these forces? These forces will be used to determine the power consumption in the cutting. How much power is consuming during the cutting operation? This we can find with the help of these cutting forces. And so when once we decide, we investigate, find the power, then we can estimate how much what type of motor and how much power of the motor we can use, the motor with how much power. So it will also help to design a machine tool, fixture and tool system. So first is force calculation. Second one, we can also calculate the friction of coefficient. That will be apparent, not real, but it is almost near to the real coefficient of friction. So we can determine coefficient of friction, that is mu. So these are the main use of this merchant circle diagram. Next, I will discuss about the what is the orthogonal cutting. Orthogonal cutting is the type of cutting in which the cutting face of the tool is at 90 degree to the line of action or feed motion, and it is a 2D type of cutting in which the radial force will be 0. And the example of the orthogonal cutting are, it is used in slotting, parting, pipe cutting, grooving. So these are the example of this orthogonal cutting. Chip thickness ratio. Chip thickness ratio, that is also called cutting ratio, which is generally represented by R. So this is R equal to T1 by T2. Now what is T1 here? T1 is this uncut chip thickness, T1. And what is T2? T2 is the chip thickness, T2. So T1 is uncut chip thickness and T2 is chip thickness. So this is the chip thickness ratio. This is very important and generally asked in the exam question related to this cutting ratio, chip thickness ratio. And the reciprocal to this chip thickness ratio is called chip reduction coefficient. Chip reduction coefficient. I am writing COEF coefficient. This is K and this is equal to reciprocal of chip thickness ratio 1 by R. So one term is chip thickness ratio, another one is chip reduction coefficient. These both are very important. Next, volume. This is one of the assumption is that volume will be constant. So volume before suppose volume before cutting, we say that volume 1 equal to volume after the cutting, volume 2. So how we will find this volume 1? This will be T1, this area we will find T1, this one is T1 into B into this length L1. T1 into B into L1. L1 is the uncut chip length. Suppose uncut chip length. And volume 2 will be T2 into B into L2. L2 is chip length. Okay. So here width is constant because B1 equal to B2 equal to B according to the assumption. So this will be the T1 by T2 equal to L2 by L1. This is an important expression which is equal to R, chip thickness ratio. So T1 by T2 equal to L2 by L1. Similarly, one more expression, volume flow rate. Volume flow rate will be constant. That is, volume flow rate will be given by T1 into B1 or B equal B into VC. VC is the, what is the VC? Cutting velocity. VC is the cutting velocity equal to T2 into B into VF. VF is the chip flow velocity, your chip velocity. So this will be equal B here B and B both sides this is same, so we this will cancel each other. So T1 by T2 is equal to VF by VC. So this is one more expression, and T1 by T2 equal to VF by VC equal to L2 by L1, and these all are equal to R, chip thickness ratio. So this is very important expression. Next we will derive a formula, that is tan phi is equal to R cos alpha divided by 1 minus R sin alpha. What is alpha here? Alpha is the rake angle. Suppose this is the vertical to this, this is a vertical line to this horizontal, and this is alpha. This is the angle made by rake face of the tool with this vertical line. This is called alpha. That is rake angle. Alpha is rake angle. And what is this? This is the shear plane. So angle made by the shear plane with the horizontal is called phi. So alpha is rake angle, and phi is the shear angle. We will derive this formula. Why we are deriving this formula? Because this will help us to draw the merchant circle diagram. This is very important to draw the merchant circle diagram because we need this phi shear angle there, and how we will calculate the phi with the help of this diagram. If we know the value of alpha and R, then we can calculate the phi. So we will derive this formula. So you don't have to remember this formula. This is not easy to remember always. So you can derive this formula very fast from this diagram. First of all, consider this triangle A, B, C. This triangle. Consider this triangle. That is, I am drawing this triangle here like this and this. This is A, B, C. This is phi. This is right angle. So this is T1. Okay. So what is sin phi? Sin phi is equal to T1 by AB. And what is value of T1 equal to AB sin phi. Similarly, consider this triangle AB. This is D point. This is D point. ABD, triangle ABD. So A, B, D. As we know that this is angle phi, and this is alpha. So this one is 90 minus phi. 90 minus phi. So this overall, this angle will be 90 minus phi plus alpha. This angle will be 90 minus phi plus alpha. So, and this one is T2. This length is T2. So, what is the sine 90 minus phi plus alpha equal to T2 divided by AB. So, what is the value of this T2? T2 equal to AB sine 90 minus phi plus alpha. So now as we know that our chip thickness ratio is equal to T1 by T2, that is equal to AB sine phi by AB sine 90 minus phi plus alpha. So this sine 90 minus phi plus alpha is equal to sine 90 minus phi minus alpha, and this will equal to cos phi minus alpha. So this will become R is equal to AB sin phi divided by cos phi minus alpha. Now we will solve this. I am removing this. So expand this cos phi minus alpha. R is equal to A. Oh, first we will. Here is AB. I forgot that AB. So AB will be cancelled by AB. So here this will be sin phi divided by cos phi minus alpha, which is equal to sin phi by cos phi cos alpha plus sin phi sin alpha. And this, now divide numerator and denominator, divide by cos phi. So R equal to sin phi divided by cos phi. I will divide there only. Divide by cos phi and divide by cos phi. So it will become tan phi cos phi cancel, and sin phi by cos phi will become tan phi. So this expression will become tan phi divided by cos alpha plus tan phi sin alpha. Now bring this part to the left hand side. It will become R cos alpha plus R tan alpha tan phi sin alpha equal to tan phi. So we bring this part to this side. R cos alpha equal to tan phi 1 minus R sin alpha. So it will become tan phi is equal to r cos alpha divided by 1 minus r sin alpha. So this was the expression for which we have put all efforts to derive this formula only. So tan phi equal to r cos alpha by 1 minus r sin alpha. So this is very important formula to draw the merchant circle diagram. Next part is the velocity triangle diagram. Velocity triangle. There are three velocities: cutting velocity, shear plane velocity. Vs is the shear plane velocity, Vf is the cutting chip velocity. So we can draw a triangle like this one is the Vf, this one is the Vs, and this is the cutting velocity. This is the Vs, this is the cutting velocity, Vc. So Vf is making an angle alpha with this perpendicular or vertical line, and so this one will be 90 minus alpha. This is phi. Shear plane is making an angle phi with the horizontal. At place of this Vf, because here it is shown at this face, we have drawn this here at this side. Okay, Vf, and this angle will be because the sum of the triangle angle of the triangle is 180, so this will be 90 minus phi plus alpha. Okay, this will become 90 minus phi plus alpha. As according to sine's law, the length of the opposite face to the angle, length of a side of a triangle will be proportional to the opposite angle. So it will be like VC is length of this side, so angle is this, sine of 90 minus phi plus alpha, okay, equal to Vs divided by sine of 90 minus alpha, sine of 90 minus alpha. Similarly for Vf, sine of Vf divided by sine of phi. So this will become Vc by cos phi minus alpha. This will become cos alpha, and this will become Vf by sin phi. So this is very important formula, but I suggest that don't remember this formula. You have to given in question you have to given value of alpha or r or something, so you can directly using the sine's law you can find the value of all other things. Like for example, you have given value of alpha 10 degree, and suppose phi is 15 degree. So draw this triangle, you know, Vs, Vc and Vf, and you have 10 alpha, so 90 minus 10, this will become 80, and 15 phi, and this will be 90 minus phi plus alpha, it will become 85. So you can find Vs divided by this sine 80, Vc divided by sine 85, and Vf divided by sine 15. So you can directly find the value, find the answer in term of this. Okay, so today I have discussed about some of the formula and basic of the merchant circle diagram, and video is going to be very lengthy, so I will stop here. and in next video I will discuss how to draw the merchant circle diagram. So I will stop here.